everyone, I am Anamika Goyal from ABES Engineering College, Ghaziabad. In today's lecture, we'll be discussing about TCP flow control and retransmission. In this lecture, first we'll discuss about the TCP flow control. After that, we'll discuss TCP flow control tools. And at last, we'll discuss about the TCP retransmission. So let's start our topic, TCP flow control. Flow control basically a control of data transmission speed. Flow control basically define the transfer speed of the data is adjusting in between two devices during data transmission. Like when we want to transmit data TCP client to TCP server, so we just have to maintain the data rate speed or to control the data rate speed between client side to server side. Let us take an example to understand the concept of TCP flow control. We can see the need of TCP flow control. Suppose client want to send some data to the server at the speed of 10 megabit per second, but TCP server is not able to process or receive these data from the client side. Now TCP server is able to process the data at the data rate of 1 megabit per second. So after some time, TCP server send the feedback to the client that I am not able to process the data with these data rates. So you can send me the data at max 1 megabit per second so that I can process these data. So this is basically the mechanism that how the flow control can be happening. So here we can say that we can control the data rate between these two computers. Flow control help maintain the reliability of TCP transmission by adjusting the rate of data flow between source and the destination for a given sessions. Now we'll discuss about the TCP flow control tools. In TCP flow control, it is maintained by using the following tool. The first one is the window scaling, second one is the window advertisement, and the third one is the persistent timers. So let us discuss these three tools one by one in detail. First one is the window scaling. Window scaling, TCP window scale option, it is the maximum window size can be increased from 65535 byte to 1 gigabyte. The TCP three-way handshake is the only time the window scale option is used. So if I'm talking about the window scaling, so let us first revise the concept of TCP communication service. TCP communication services can be categorized into three different phases: connection establishment, data transfer, and connection termination phase. So window scaling option or window scaling tool can be used or to apply at the time where the connection establishment phase is used. So to understand this, let us take an example, right? So here what happened here? We have, let us suppose this is what, this is a client and this one is the server, right? So this is what, this is client A and this one server B. So before transmitting the data using TCP protocol, what happened? First, we have to establish the connection. So into establishing connection, first client will send a request message to the server V, right? So client send a request message to the server V. At the time of request message, client also send it buffer size, that is window size. For example, in that case, it is 3000 byte. So in that case, the client buffer size is 3000 byte. At the same time, server also reply the client request message and at the time of this reply message, server is also send its window size. For example, it will be 2000 bytes. So the receiver window size is 2000 byte. Right. So what happened in this moment, the client window sizes is 3000 bytes. So client can store at max 3000 byte of information. Receiver window sizes is 2000 byte. That is server can store at max 2000 byte of data. So after that, what happened? Client will also acknowledge the server reply message using ACK command. So what happened here? This is what? This is the TCP connection establishment phase. First phase of the TCP protocol, right? So what happened in that case, the client buffer size is 3000 and the server buffer size is 2000. So both of these computer will agree upon the lower of these two window size. So here the window sizes is 2000. So in the connection establishment phase, both of these computer will agree the window size, that is the lower of these two value, that will be 2000. So the sender window size is 2000, the receiver window size is also a 2000. So that is nothing but it is a window scaling options. I hope you understand the concept of window scaling. This is the flow control mechanism, right? Second tool to control the flow control. The second one is the window advertisement tools. So to understand the window advertisement tool, let us continue our example. Right. So this one again, this one is the client window and this one is the receiver window. Okay. So at the time of this is client A and this is server V. So at the time of connection establishment phase, the window scaling option is done. So according to window scaling, the client buffer size is 2000 and the server buffer size is also 2000 byte, right? So after establishment of the connection data transfer phase, with the help of data transfer phase, client can send some data to the server. Like client initially send 1000 byte of data to the server. So what happened, the server windows, when server receive this data, so server half window will be filled and the remaining window size is 1000 byte. So in that case, server will send the feedback to the client with its available window size, that is the blue window size is 1000 byte. So what is this? This is called window advertisement. In window advertisement, what happened? The process by which a receiving host inform the sender about the amount of data it can currently accept. Right? So it may be possible after sending more data like 1000 more byte or send with the client to the server. So what happened in that case? When server will receive these 1000 bytes, so the server buffer will completely fill. Okay. So in that case, server will also advertise their window size, that is 0. So when client will receive the server window size 0, the client will stop the data transmitting further, because in that case if the client will send data, the data will be lost. So in that case what happens, the client will stop the transmission process. So this is the another mechanism to control the flow, right? Third tool for flow control is persistent timer. Persistent timer is basically used in the case to avoid the deadlock condition, right? In TCP protocol, to avoid deadlock condition, basically we use persistent timer tool. To understand the concept of persistent timer, again, we'll continue our example. This is a client and this is a server. In first phase, we have to establish the connection. After establishment of the connection in data transfer phase, client can send more and more amount of data, and after that when server reply that window size is 0, so client further will stop the data transmission because the client and server buffer are full, right? So this is a window advertisement. But after some time, when the filled buffer will send data to the application layer, it may be possible that this buffer is maybe empty. So it may be possible the available window size in that case may be 1000 bytes. So in that case, what happened when these filled buffers send information to the application layer? So again, this server will send feedback with its available window size, that is 1000 byte to client. Maybe suppose in that case this message will lost. So what happened? In that case, what happened? Actually, in that case, client will assume that the server buffer is filled, so client don't send data, but server have the capacity for storing more data. So if this, if so, this is the deadlock condition, because in that case client वेट कर रहा है कि वो सर्वर को डेटा भेजेगा, और सर्वर वेट कर रहा है कि उसने क्लाइंट को अपना विंडो साइज भेज दिया है तो क्लाइंट की तरफ से इंफॉर्मेशन आएगी, बट क्लाइंट को वो मैसेज नहीं मिला. सो व्हाट इज दिस कंडीशन इज कॉल्ड डेडलॉक कंडीशन. सो टू अवॉइड दिस कंडीशन, व्हाट हैपेन आफ्टर सम period of time, that is called persistent timer. After waiting some period of time, that is persistent timer, what happened? Client will send a probe message. Probe message, this message does not contain any kind of data, right? So client will send a probe message to the server to actually ask the server that is there any space in your buffer for further transmissions? Are you ready? So if a server will reply this message using with its available window size, that is 1000 bytes. So what happened in that case? Client will send again more data for the server. So this is called persistent timer. So in order to handle a deadlock with zero window size, TCP employ a persistent timer. So basically to handle the zero window size facility, we also use these concepts. So this is all about TCP flow control, right? I hope to understand the concept of TCP flow control. Our next topic is the TCP retransmissions. Now TCP retransmission. The retransmissions mean retransmission is nothing but it is a retransmission packet over the network that have been lost or corrupted is known as TCP retransmission. Basically, retransmission when clients send a message to the server, it may be possible the server the data packet would be lost. So when client not does not receive any kind of acknowledgement, so he can guess that that maybe the data loss or corruption. So they again retransmit the data. This process is called retransmission. Now we'll discuss the retransmission strategy. Retransmission possible in three cases. First, we'll discuss about the case one. Case one is when the data packet is lost. Okay? Right. When we perform the retransmission in that case, when the data packet is lost. Like to understand that case one, let us suppose we have a client A and server B. Client A send a packet one to the server, but due to some reason, maybe packet 1 is lost. ठीक, so after waiting some timeout period, if client does not receive any kind of acknowledgement of packet 1, so client will again retransmit the packet, and after sending these packets, server will acknowledge the client within a specified time period. So this is a TCP retransmission when the data packet is lost. Second case of TCP retransmission when the packet is received but acknowledgement is lost. To understand this again, let us take an example of TCP client and server. Client send a packet 1 to the server, and server after receiving this packet, server will send acknowledgement to the client, but it may be due to some network error, this acknowledgement will lose. But and after waiting certain time of period, if client not receive any kind of acknowledgement, so client assume that it may be data loss or corrupted, so it can again retransmit these packet one to the server. So this is the case two. Third possibility of TCP retransmission is when the early timeout occurs. To understand this, the packet is sent, but it is retransmitted because of the acknowledgement delay. It means when TCP client send packet 1 to the server, server will receive, after receiving this packet 1, server will send an acknowledgement. But due to some network error, it may be possible that that is some delay in acknowledgement packet, and after waiting certain timeout a certain amount of time, what happened if client does not receive any kind of acknowledgement, so client again resend the packet one, but the client will also receive acknowledgement, but due to some delay, it means server send the acknowledgement of packet one, but maybe due to some delay, client wait certain amount of time period, and if this given time period, if client does not receive any kind of acknowledgement, so client will resend the package. So this is early timeout retransmission. So this is all about TCP retransmission. These are the references used to design this lecture. Thank you for your patience listening.